the diffraction due to a single slit, what we have observed, see like this. So what was diffraction? The light was entering the geometrical shadow area, correct? So what we are looking at is a single slit. So we have a single slit, we have the lens. So why we used L1? L1 is because to get a plane wavefront. L2 is to converge the light, right? Okay, now here the very important point what we have to look at it is triangle ABN. Okay, now in triangle ABN, that BN distance is nothing but the path difference, correct? So the path difference between the wavefront which leaves from A and which leaves from B. The BN is the path difference. So if we need to get a dark fringe or a bright fringe, then it all depends on the length BA, right? So if it has to be a dark fringe, then the path difference has to be an integral multiple of lambda, because if, see, we are dividing it into two equal parts, correct? So if it has to be a dark fringe, then the let's say a wavefront leaving at A and a wavefront leaving at B, if the path difference becomes 1 lambda, then if there is a crust, then here it will be trough. Then if at point A, if it's a trough, then at point B it will be a crust, right? So the difference is 1 lambda, then we are going to get a minimum, or we can say a dark fringe. So using that, we have in triangle ABN, sin theta is equal to BN divided by AB, or if let's say theta is equal to theta 1, then we have sin theta 1 is equal to lambda by A, right? So this is the first secondary minimum. Now for the second secondary minimum, we have sin theta 2 is equal to 2 lambda divided by A. Similarly, sin theta n is equal to n lambda by A, correct? Now the distance of the dark fringe or the minimum, yn is equal to n d lambda divided by A. This we got it by comparing the two angles, that is tan theta n and sin theta n, correct? We got that. Now for a maximum, what we have was, it has to be an odd multiple of lambda, correct? So if Bn is 3 lambda by 2, then we have sin theta 1 is equal to 3 lambda divided by 2a. This will be the first secondary maximum. Similarly, if sin theta 2 is equal to 5 lambda by 2a, then it is second secondary maximum. Or in other words, if it is 2n plus 1 into lambda divided by 2a, then it is an nth maximum, right? The distance of the nth maximum was given by 2n plus 1 into d lambda divided by 2a, right? So this is what we had learnt in the derivation. So basically the entire summary of diffraction. But here very important point is the secondary maximum or the secondary minimum is of the same width, because the beta value was the same for both of them, correct? Whereas the central maximum is twice that of the secondary maximum or secondary minimum. So this is what we got. So beta naught is equal to 2 d lambda divided by A, correct? So this is the central maximum, and for any other dark fringe or a bright fringe, we have d lambda divided by A. Okay, so the diffraction goes, or the diffraction happens whenever the size of the particle is comparable with the wavelength of the light. Okay, only then diffraction happens. Lots of examples also, you guys have to think about it, come up with different examples. In the next video, you guys will see how problems can be solved using these formulas.